Hello everyone, welcome to my capstone prototype presentation. My name is Moy Siddiqui and I am the lead designer and developer of project Cyber3D99. I am pleased to finally be able to show everyone what I've been working on these few months of the fall semester. I've been incorporating aspects of coursework we have learned throughout the semester, from engines to AI to physics to networking, although my networking could use some more additional work, but we'll get to that in a bit. For my final year capstone project at Humber College, I will be working on a third-person shooter titled Project Cyber3D99. The genre of my game is a 3D platformer / shoot 'em up. The desired choice of a platformer and shoot 'em up mix was chosen because I believe combining these two will provide players a real sense of challenge and excitement. My main influences are Mega Man for platforming and Cyberpunk 2077 for design and aesthetics. During their gameplay experience, the player will be maneuvering throughout various levels using platforming mechanics, including the usage of a jetpack. While the player is moving throughout the level, he will face a large number of enemies that he will have to face to defeat with the use of his multiple weapons and power-ups. This will cause the player to get an adrenaline rush experience. To complete the level, the player must go through a boss fight. At the same time, the player will be collecting in-game currency called hollow coins, which they will use to upgrade or change weapons and their appearances. I am now going to walk you through my capstone. First off is the game engine. I am using the latest Unity 2020 release with the Universal Render pipeline. The reason I have chosen to use this pipeline is because of the access to extra features such as advanced post-processing and shaders. The content we learned in class, such as GUI system, particle system, audio system, and custom editor tools, I have implemented them in a way that fits with what I'm building towards. So first of all, we'll go over the GUI. The type of canvas I'm using here is the world space canvas. This allows me to make dynamic UI that is interactable with the player. For instance, I can attach two game objects and make them act as buttons or navigation. Another thing you'll notice is the button sounds. When I hover or click my UI buttons, they will play back in audio. I can also adjust this in my game settings like so. I can also control the game's resolution. I can toggle screen mode. However, this only works once the game has been built. And the render quality. Over here at the market option, you'll be able to purchase and customize your character. Later in the program, I will look into creating a fully functional character customizer that the player can use, but for now I have made an editor tool that mimics what I want to implement down the road. Here you can rotate and view the character, change the scale, browse through skins, and for editor purposes, set text. Let's look into the player movements and physics now. I have so far created fluid and responsive third-person movement. We have collision and mass applied to our player. This is thanks to Unity's rigid body system. I have yet to include a jetpack system and jumping though. This is still on the list and will be ready by next semester for the final capstone showcase. All the bone movement you see in our player's skeleton is handled through this new system Unity introduced called animation rigging. It allows me to control the weight of the bones and how it reacts to what the player is holding. For example, when I pick up these weapons, it uses a combination of keyframe animation and rig weight controls. My bullets have an impact force as well. They can push objects that also have rigid bodies. One of the most exciting parts of this semester has been learning different ways we can create artificial intelligence, such as steering, nav mesh, hard coding, patrol paths, AStar method, and behavior trees. We are first going to look at a very simple AI that uses nav mesh. This enemy here uses Unity's nav mesh surface to navigate itself around our level. I added gizmos to represent the AI's sight range. The yellow sphere represents the chase range, and the red sphere is if the player is within those bounds, the enemy will start shooting projectiles. Next, we have the hard-coded enemy. This AI does not use nav mesh, however it calculates and looks for its next target waypoints. We can create as many waypoints we want, and it will go through them using indexes in order. I did not get the opportunity to add in any chase functions for this. Up next is the AStar method. Let's do a quick explanation on how this works. We first need to create nodes and a grid for it to calculate its path. Next, we need to look for the distance between the starting position and the goal destination. This is essentially calculated through costs, G cost being the distance from the starting node, H cost being the distance from the end node, and F cost being the sum of G cost and H cost. I have two different ways I would like to show you this method. First being a custom implementation that uses these two cubes as starting and end nodes. A green line is shown to highlight the paths. As you can see, we have layer mask applied to obstacles, so it calculates around them as well. The second method I want to show is a plugin for Unity. This works perfectly with moving game objects. Lastly, the behavior tree. The behavior tree has a parent node that will have a certain amount of children. In my example, I have 3 sequences. These sequences are called cover, shooting, and chase. The cover sequence being the most complex of them all, it will take in a health node and a cover node. The way this works is that if the enemy reaches a certain health threshold, Let's say the total health of our enemy is 100 and it goes down to 40 by receiving damage from our player. It will look for certain areas that it can hide behind and slowly regain its health. When that's all said and done, it will go back to chasing our player. Unfortunately, I could not get this to work. However, the other two sequences, chase and shoot, do function properly. The enemy will turn yellow, indicating their target is in sight and will pursue. It will then change to green, indicating that the target is close enough to be attacked. Implementing online networking posed the greatest challenge, as it is something I have not experienced yet. I was tasked to implement a form of spectator mode where one person will play as the main player and another will get to use a drone to act as a camera so they can assist or watch the main player. To acquire online features in the project, I used one of the popular networking infrastructure called Photon. I was able to at first successfully access their servers and create lobbies. I was then able to add basic players into the lobby, but when it got to adding the actual player and drone game objects, this is where difficulty landed. I had trouble syncing animations, letting the players select who they want to play as, and the camera prioritizing the correct game object. This was an interesting learning outcome, and I'll work in the future to correct these mistakes. To summarize my learning outcome in this fall semester, I would say I accomplished most of my goals that were needed of me. While it is obvious that I have to tweak and fix certain implementations, I would say I learned quite a bit, especially from physics and artificial intelligence. These two helped me shape my gameplay experience to a new level. I have much to learn still, and I look forward to sharing the final product in 2021. I hope you enjoyed my presentation, and thank you for watching.